All right, greetings, Saintsmen. We're going to move on to working with lesson 2.4, which is solving a multi-step inequality. One of the tricks that we're going to see here is this notion of multiplying and dividing by a negative rather than multiplying or dividing a negative. So here's our first example. We have x over negative 2 plus 4 greater than negative 1. So again, we're trying to isolate that variable x. So our first step is that we will subtract 4 from both sides, which is going to eliminate the 4 on the other end, right? Because the first thing is that we can look at this and think about, oh, can I treat this like an equation, okay? Which it's not, right? It's actually an inequality. So once we do that, we're gonna have x over negative 2 by itself on the left. And then we're gonna, of course, we have canceled 4, negative 4. Negative 1 minus 4 is negative 5, okay? And our last step here, multiplying both sides by negative 2. Okay, the negative 2's are going to factor out. So x, and we're going to have negative 5 times negative 2, which of course is negative 10. But remember, when you multiply by a negative, we have to reverse our sign. So it's no longer greater than, it is now less than. Can we graph this? Well, absolutely. Remember what my two points that I need on here. This is an error that I saw on some of your work on the most recent quiz. So we have to put negative 10 and 0 in the correct order, right? Negative 10 would go on the left, and then 0 is going to go on the right. So make sure that we're doing that. We have an open or a closed dot, which is going to be open in this case, and then we need to shade to one direction. So we're going to shade into the left on the line and include the arrow, of course. And there you go, there's your graph for the same inequality, okay? What's nice is that, of course, we can shade to the left because, again, the inequality points to the left. Sorry, it's positive 10. Positive 10. Yeah, negative times a negative gives the positive, and that arrow pointing left, meaning we're going to shade to the left. As long as our variable is present over here on the left, we can use that little trick. Okay, so next, we have 3c minus 2 less than or equal to negative 11. Okay, so step 1. Of course, we're going to add 2 to both sides, right? Which is going to cancel out our negative 2 on the left, leaving us with 3c less than or equal to. We have negative 11 plus 2, which is going to be a negative 9 when we combine those. Next, we need to get the c by itself, so we're going to divide both sides by 3 so that we can factor out the 3. C is going to be less than or equal to negative 9 divided by 3 is negative 3. Wait, hold on, guys. Take a look at this. We divided negative 9, so we need to flip our sign, correct? And that would be not the case. When we divide by a negative, not when we divide a negative, is when we are going to switch that sign. So, again, I only need 2 tick marks on here, right? Which is negative 3 and 0, putting them in the correct order. Having an open or a closed dot. Of course, my dot is closed. And then to which direction am I shading, right? Well, take a look here. Your inequality points to the left, so we are going to shade to the left. All right. And then these problems are going to get very quickly a little bit more exotic, right? So we have 5x minus 6 greater than or equal to 3x plus 4. Now we're dealing with, this is just like what we did in the previous chapter, just like when we solve an equation with a variable on both sides, right? So we need to move the variable all to one side. It doesn't matter which one. I think it's best if we tend to move it over to the left. We're trying to get the variable isolated on the left. That way we don't have to flip our inequality at the end. So step one is I'm going to add 6 to both sides because I'm going to gather all my x's on the left. So now I have just a 5x by itself, still greater than or equal to, right? Because I canceled out my -6. 3x gets copied down, and then 4 plus 6 is going to be a plus 10. My next step, I'm going to subtract a 3x from both sides, okay? So gathering all my x's on the left, I'm going to cancel out the x on the right. And of course, you could do it the other way, right? We could actually gather all of our x's on the right, but I just chose to do it on the left. And if we do it correct, we're going to get the same answer in both cases. 5x minus 3x is going to give us just 2 x's, greater than or equal to, right? The 3x and the minus 3x are going to cancel out, and we have a positive 10. Next step, we're going to divide it by 2 on both sides, right? Our 2's are going to factor out. X is by itself on the left. Less than or equal to. We divided by a positive, so our sign isn't going to change. 10 divided by 2 is 5. And we've got it. So, getting back to this problem, how we're going to graph it, right? I have 2 tick marks. My only requirement, right? Just showing where its relationship is to 0. So 0 is going to go on the left, and the 5 will go on the right. It's a closed dot, right? Because it's equal. And then our inequality points to the right, so we will shade to the right, okay? Again, when our variable is on the left, we can use the direction that the inequality points as guidance, right? And of course, we read that as x greater than or equal to 5. When we shade to the right, it demonstrates the greater than idea in the inequality. All right. Solve a few more of these. We have 6t minus 4 greater than 2 times the quantity 3t plus 5. This is going to be a fun example. A few things are going to happen here. First, it's this. We have parentheses where we're going to be able to distribute the 2. So I always remember I like to draw those distribution lines so that I don't forget to distribute to the second term, because that's a common mistake on these problems. So 6t minus 4 gets copied down, still greater than. Then we have 2 times 3t, which is 6t, and we have 2 times positive 5, which is positive 10. So let's keep going. I'm going to add 4 to both sides, right? Because I'm going to try to gather my variables all on one side. So I'm going to try to do that on the left, right? So 6t minus 4 plus 4 cancels, so I have greater than 6t. And then I have 10 plus 4, which is 14. Okay? Next step. I take away 6t from both sides. (6t minus 6t), oh goodness, that's going to cancel as well. That's going to leave me 0, greater than 14. Now, read that to yourself. 0 greater than 14. That makes no sense. It is not greater than it. It's smaller, right? That's a false statement. If that's a false statement, what does this mean? Well, this means that there is no solution. Okay? Can we graph no solution? No. You're not going to be bothered with that. So 2 times the quantity, 2x minus 3 less than or equal to 9 plus 4x. All right, well, again, we see those distribution, or excuse me, those parentheses, which our instinct should be to distribute, and that's fine. So we have 4x minus 6 less than or equal to 9 plus 4x. Okay. And let's go ahead and get rid of that 4x, right? From both sides. Because can we do it in either order? Sure, we could go after the variable first. There's no reason why not. And it's going to cancel both sides. So I have negative 6 less than or equal to 9. Now, if I had gone about getting rid of the constant terms here, right, this negative 6 and the 9 and grouping those together and then moving the 4x from the right and just subtracting it from both sides, right and left, I'm going to get the same result, which is this statement right here, negative 6 less than or equal to 9, which is true. This is true. Negative 6 is less than 9. So it means that all real numbers are going to be your solution for x, right? Any real number you put in for x will work. You will see also mathematicians abbreviate this to all reals, which is kind of sounds funny. When it's all real numbers, there's nothing for us to graph, okay? What we technically could graph is this. If you guys really wanted to graph no solution would just be the number line. You put 0 on there. Nothing graphed, right? All reals, it's the number line. Here's 0, right? And you would just shade in the whole thing. This is technically what the graph would be, right? It's any number on the number line. But I don't need you guys to do that. When we have no solution or all real numbers as our answer, I don't need you guys to provide me the graph. Only when we have it for our other inequalities. Okay. And let's go ahead and do one more example. This is a favorite of mine. This is a real life problem from my life from back in college, where I did poorly on a couple of math tests to start, and I had to figure out how well I needed to do on my last 3 exams in order to get a certain grade in the class. So your grades on 4 math tests are 79, 85, 86, and 88. You want your mean grade to be at least 85. What grade on your 5th test will give you a mean score of at least 85? We got to do a little bit of deciphering with this thing, because we see this thing mean right here, right? This word. And the word mean mathematically is your arithmetic average. Okay? Remember how we find the average of things. We're going to add all of the numbers together, and you divide by the number of numbers. Like, for example, if we want the average of 4, 4, and 6, right? Well, what you do here is you're going to take 4 plus 4 plus 6, which is 14, and you're going to divide 14 by the number of numbers, which is 3. So your answer here is 4 and 2/3. That would be your average of 4, 4, and 6. It's a measure of central tendency, right? So the way we're going to do this is we have 5 tests that we're looking at, right? There's the 4 that you've already taken, where you've gotten a 79, an 85, an 86, an 88, right? In the 5th test, we haven't taken yet. That's our unknown, which we will say x. we're going to divide by the number of tests, including the one you have not taken. There are 5 tests that we're looking for. Now, we have to go here and see what grade on the 5th test will give you a score of at least, right? At least is our key here. Remember how we do at least. At least would be equal to or more than or greater than or equal to, and it says at least 85. So now we have this set up as an inequality, okay? This is going to be a good time. You guys are going to have to add this up on your own. Little side calculation, which 79 plus 85 plus 86 plus 88 is equal to 338 plus x all over 5 greater than or equal to 85. How do we get the x by itself? Well, the first thing we have to do is we need to multiply it by 5 so we can factor that guy out on the right. And if we do that, let's do it on the left. And if we do that on the left, then we have it on our right. So I have 338 plus x greater than or equal to whatever 85 times 5 is, right? Which in this case is 425. And I'm very confident on the side you can do 85 times 5. Our next step, we're going to get the x by itself by subtracting 338. It's going to cancel out on the left. Now our x is by itself. So our x, the unknown being our last test score, our 5th test score, is whatever the difference of 425 and 338 is. That is an 87. Okay? So you need at least an 87 to get the 85. Gentlemen, this is the sort of thing that you do when you're trying to figure out, obviously what you need to get a certain score in a class. There's a weighted average that you can use. Like, for example, not all of the things are worth the same. Your final exam is the thing where people try to figure this out, right? Which is 15% of your grade. When you do that, you take your current grade, which is 85%, right? For all the things you've done going into the final exam. So you're going to take that percentage and multiply it times 85%. And it's going to be plus your unknown, your test score, but times 15%. And that's how you're going to try to figure out what's going to be that minimum score. And you just give a percentage, 90% for A minus, 80% for B minus, so on and so forth, okay? So just something for you guys to consider as we go forward. If you have any questions, of course, you can reach out to me via email. Your assignment is posted on Canvas. Good luck.